Fine. In the last lecture we have seen all the exceptions and everything we have seen, है ना? यहाँ पे काफी सारी चीजें हमने देखी थी. For example, in the ionization enthalpy of second and third period element, we talked about beryllium and uh, the difference between nitrogen and oxygen. Then we did for carbon, nitrogen, oxygen, fluorine, then sodium, magnesium, aluminum, silicon, you know, lithium and beryllium, first and second ionization enthalpy of lithium, beryllium. Then in boron family, we have seen some exceptions. Okay. Now, like, the way we have done this for आगे के थर्ड पीरियड एलिमेंट्स में हम लोगों ने दे दिया था ना. चलिए ठीक है. ओके, देन मोस्ट ऑफ द थिंग्स. चलिए, इतनी मेजॉरिटी आपको जरूरत रहती है. नेक्स्ट इज इलेक्ट्रॉन गेन एंथैल्पी. इलेक्ट्रॉन गेन एंथैल्पी. Electron gain enthalpy, that is written as delta H Eg. Fine. So what is electron gain enthalpy? Electron gain enthalpy is when you add, when you convert a gaseous 1 mole of gaseous atom to its anion, like this. Whatever the enthalpy change occurs here, that is, whatever the enthalpy change occurs here, that is known as the electron gain enthalpy. अगर हम यहाँ पे बात करें आपके पास, then what should happen? What should be the enthalpy change? Whether the energy is going to be released or whether the energy is going to be required in this particular process, then please see. For example, we have a nucleus. This nucleus is having 11 protons. This is the first shell, this is the second shell, and this is the third shell. Right? In the first shell, we have 2 electrons. In the second shell, we have 1, 2, 3, 4, 5, 6, 7, and 8 electrons. So total, we have 10 electrons and 1 electron in the third shell. So here the nucleus is attracting all the 11 electrons. So in total, there are 11 attractions. When you are going to add one electron, the whole system will be same. There will be an addition of one electron. And what would happen in then? Then in that case, this is the new electron that we have added here. This new electron will also be attracted by the proton in the nucleus, and there will be 12 attractors. And when the attraction is going to be more than the repulsion between the electron that is present here. Now, this electron is present, so this electron will be repelling it, but only one electron is repelling it, and there are 11 protons which are attracting. So overall, the attraction is going to win. And till the time attraction is going to be greater than repulsion, then in those times the energy or the enthalpy change in this particular process will be exothermic. There will be a release in energy. Because what is happening overall, there is an increase in the attraction. There is an increase in the attraction. Obviously, this is in general. Okay, so what is first of all electron gain enthalpy? The enthalpy change when 1 mole of gaseous atom is converted to gaseous anion. It's converted to gaseous anion. Okay, so generally what happens? Generally, energy is released on addition of electron to an atom. Therefore, delta H Eg has or usually has negative value. Now, there is a similar word that is generally used like with electron gain enthalpy. That word is electron affinity. Okay, even the NCERT has just mentioned like in what you can say at the end of a page about electron affinity. Okay, so but we need to know what is electron affinity also. Write this down till here. Let me know once you're done. Now there is a similar one word that is used which we will call electron affinity. Electron affinity. And one word that we already know that is delta H, e.g. electron gain enthalpy that the NCERT use. I mean NCERT uses it. Okay, so what is this electron affinity? Tendency to gain electron. Tendency to gain electron. What is delta H, e.g.? It is just an enthalpy change. ये आपको बस ये आइडिया देगा एनर्जी रिलीज होगी या फिर एनर्जी एब्जॉर्ब होगी, नथिंग एल्स है ना. इट इज नॉट गोइंग टू गिव यू एनी आइडिया, बट वी आर गोइंग टू रिलेट इट विद द इलेक्ट्रॉन एफिनिटी एंड डेल्टा एच इज फाइन. If the tendency to gain electron is more, tendency to gain electron is more, then what we will say electron affinity it is also more. And delta H Eg, see, whenever there is a gain in electron, whenever there is a gain in electron, it will be accompanied with electron, it will be accompanied with energy release. A release of energy is accompanied whenever there is an addition of electron. So if the tendency to gain electron is high, electron affinity will be high, delta H Eg will be more negative. What is the meaning of more negative? Negative means release of energy, more means more release of energy. Does this make sense? Yes or no? Please tell me.
Yes, sir.
Yeah? Okay. Now, similarly, when the tendency to gain electron is low, the electron affinity will also be low. And in that case, electron gain enthalpy is going to be less negative. Tendency of electron. Do you want to eat? Yes, I want to eat. भूख लगी है? हाँ लगी है. कितनी लगी है? बहुत ज्यादा. तो बहुत ज्यादा खाइएगा. You will get more energy. You will get more energy. भूख लगी है? कम लगी. कितनी भूख लगी है? कम लगी. तो कम खाइएगा. Less energy. Fine. So when the tendency to eat electron is more, the electron affinity is more, and there is a more release of energy, more negative. Enthalpy change is more negative. See, the negative part is only talking about the direction of heat change, whether the energy is released or the energy is required. How much energy, that more and less is it. Or there will be some elements which will not have any tendency to eat electron. Tendency is nothing. खाना खाइएगा? नहीं, खाना तो नहीं खाएंगे. इलेक्ट्रॉन एफिनिटी विल बी जीरो. बट जबरदस्ती अगर आपको इलेक्ट्रॉन खिला दिया जाए, देन डेल्टा एच ईटी विल बी पॉजिटिव. इन दैट केस यू विल हैव टू गिव एनर्जी in order to in order to add the electron. Now this positive will be in two cases. Noble gases, obviously, because noble gases they have the most stable inert gas electronic configuration, and that is why they will not allow any disturbance in their electronic configuration. Now, another case is where the delta H Eg is positive, where the tendency to eat electron is zero, and electron affinity is zero, where you have to put energy in order to add the electron. It will be nitrogen, phosphorus, my bad, beryllium, and magnesium. These are the three elements in which we have a very low, in which we don't have any tendency to eat electron. The electron affinity is zero. Electron gain enthalpy is positive. That means they don't have any tendency to gain electron. But if you are going to give them electron, you will have to give energy in order to make them gain electron. So this is the relation between electron affinity and delta H. If you want to write, there is a equation also given, but this equation is not really important. So delta H is equal to minus electron affinity minus 5 by 2 RT. ये important नहीं है, लेकिन this is given in the NCERT. Raise your hand once you're done. Waiting for Alina. Okay, so this is about what is electron gain enthalpy. Now we are going to look at the factors affecting electron gain enthalpy. Factors affecting electron gain enthalpy, electron affinity. ठीक है, अगर देखिए when the electron affinity, चलिए ठीक है, आपको एनसीईआरटी की लैंग्वेज बता देते हैं. नंबर वन बताइए आप हमको, है ना? यू गाइस विल टेल मी. If there is more attraction, then there will be more energy release and the addition of electron will be easier. ये फंडा आपको समझ में है ना? We have to look at, see, in ionization enthalpy, what we have to look, when we are removing the electron, we are going to look at that electron which is being removed, how much attraction it is having with the nucleus. If it is having high attraction, then we'll have to give more energy to remove that electron. Now, in electron gain enthalpy, what we have to see? We have to see that the electron, the incoming electron is feeling how much attraction. If the incoming electron is feeling high attraction, then it will be easy to add the electron. But if the incoming electron is experiencing low attraction, then it will be difficult to, the tendency to gain electron will be less. समझिए मैं आगे बात सबको, हाँ ना बताएं, अबीर, अलीना एंड अली.
Yes, sir.
ठीक है. So this is one atom. Please don't draw. This is the nucleus here. This is another atom. This is the nucleus here. The incoming electron is here. The incoming electron is here. Case A and case B. In which case do you think there will be more attraction? A case or B case? Where will the electron feel more attraction?
A.
In A case, right? Why? Because it is nearer to the positive charge. So we
Yes,
can
sir.
say that size. Size increases, delta HEG decreases. When I say delta HEG decreases, आप ये ध्यान रखिएगा, it is less negative. Does this make sense? Yes or no? Please tell me. बोलो
Yes, sir.
अबीर. ठीक है, delta HEG is less negative, and we can also say the electron affinity is also low. Fine. That means we can say that electron affinity, the tendency to gain electron, is inversely proportional to size. Second, let's suppose the size is same, but here you have 11 positive charge, and in the nucleus there is 11 proton, and here in the nucleus we have 17 proton. And now in this case, tell me the incoming electron, where will it feel more attraction, in the A case or the B case? Where will it feel more
Sir,
attraction? In the B
B
case, right?
case.
Because we have, yeah, correct. In the B case, because there is more proton, it will be feeling more attractive. That means effective nuclear charge is also one of the factors. If Z effective is high, electron gain enthalpy will be highly negative. And similarly, electron affinity will also be high. The tendency to gain electron will be also high. So electron affinity, it is directly proportional to Z effective. Make sense, everyone? Yes or no? Please tell me.
Yes, sir.
नेक्स्ट लिखिएगा थर्ड, noble gases, half filled and fully filled electronic configuration. Because they are half filled, fully filled electronic configuration, they will resist the addition of electrons. Noble configuration resist the addition of electron. मतलब फोर्थ वाला जो है दिस इज क्वाइट इंपॉर्टेंट तो नहीं है बट इसको समझना थोड़ा सा जरूरी है ना, समझिएगा जरा। आई एम गोइंग टू कंपेयर सोडियम एंड एल्यूमिनियम, ठीक है ना, ध्यान से देखिएगा। ऑल ऑफ यू डन टिल थर्ड पॉइंट, यस और नो प्लीज टेल मी।
Yes, sir.
ठीक है, ध्यान दीजिएगा। सोडियम, ठीक है, एंड इन दैट वी आर गोइंग टू ऐड इलेक्ट्रॉन। सोडियम इज 1s2 2s2 2p6 3s1। if you add electron it will become sodium negative, it will be 1s2 2s2 2p6 3s2। incoming electron in s subshell, थर्ड शेल के s subshell में। in aluminium 1s2 1s2 2s2 2p6 3s2 3p1। add one electron 1s2 2s2 2p6 3s2 3p2। incoming electron in p subshell। समझ में आ रही है, आया ना बताएं। clear, everything is fine। now you guys tell me
Yes.
s subshell, since it is closer to the nucleus na, s subshell is closer to the nucleus, s subshell is like this। even in the nucleus there is a high probability of finding the there is a high probability of finding the electron। s subshell ke electron, if the electron is in the s subshell it is going to feel more attraction rather than in the p subshell। that is why if there is any element whose configuration is ns1, this will have higher electron affinity than np1। does this make sense?
Yes, sir.
फोर्थ फैक्टर में क्या लिख देंगे, ns1 configuration has higher electron affinity than np। after this we are going to write the friends see across a period what happens, across the period the z effective increases, size decreases, therefore electron affinity will be high। give me a second, electron affinity will be high and delta H is more negative। top to bottom in a group, z effective is constant, size increases, therefore electron affinity decreases and delta H will be less negative। copy this down, raise your hand once you're done। Just waiting for Alina. All of you understood the trend also? Yes or no? Please tell me.
Yes, sir.
Sir.
Next देखिएगा exception. The first exception is noble gas, nitrogen, beryllium, and magnesium have positive electron gain enthalpy. That is endothermic. Reason? Noble gas में क्या होता है? Inert electronic configuration, and electron is added in a new shell. Now, for example, अगर हम neon की बात करें, then neon is going to have two shells. Electronic configuration is 10, na? 2 and 8 electrons in the second shell. If you're going to add one more electron, that is going to go to the third shell. Fine, that is going to go to the third shell. Now, the neon only has 10 proton. 10 proton maximum, it can hold up to how much? It can hold up to 2 shell. But if you are going to give the electron in the third shell, it will be very difficult for the 10 protons to attract the electron from the third shell, because third shell is very far away. That is why the repulsion, whatever it is, the electron, it is going to feel repulsion because of the inner shell electron, that is the sigma, what we call as the shielding effect. And it is also experiencing what? 10 protons. अब इस बात को समझिए that it is experiencing a pull from the 10 protons, and it is also experiencing a repulsion from the 10 electrons. The 10 protons, they are very far away from that particular electron, but this 8 electrons from here, they are also what, repelling this electron. No? That is why we have to add energy in order to what? In order to add the electron. We have to give energy in order to add the electron. So this has inert electronic configuration, and electron is added in a new shell. That is why noble gas configuration has positive electron gain enthalpy. नाइट्रोजन के केस में नाइट्रोजन हैज 2p3 configuration and small size. Therefore, energy is required. What about beryllium and magnesium? Now, देखिए beryllium और magnesium में क्या होता है? Both has beryllium के पास जो configuration है ना, that is going to be 1s2 and 2s2. Magnesium, it is having neon 3s2. If you are going to add electron in these two, then आपके पास configuration Be negative and Mg negative. Be negative configuration will be 1s2, 2s2, 2p1. Manganese negative will be neon and 3s2, 3p1. Now, when the manganese, it was a neutral atom, the proton of manganese, it had to hold the electron of the s subshell only. Now, there is a huge change when you go from s subshell to p subshell. P subshell is very, if I compare to s subshell, it is further away from the nucleus. S subshell is just, S subshell is how close to the nucleus? It is in the nucleus. इतना क्यों समझ लीजिए आप? If you look at the probability density diagram ना, अगर आप देखेंगे इस तरह का ग्राफ बनता है, as you get closer to the nucleus, the probability of finding the s electron, it becomes higher and higher and higher. तो बिल्कुल ही न्यूक्लियस के नजदीक कौन मिलेगा आपको? You will get s. And if you consider the p, then p is further away, and that is why what happens? This incoming electron, it does not experience the attraction it is required to experience. What happens? P subshell is far away, therefore less attraction. Topic is down. Raise your hand once you're done. Waiting for Alina. Festival, right? Second, delta H Eg of second period element. Fine. So we are going to look at the trend now. How the second period elements have. Okay, clear. Now the second period elements are lithium. After lithium, what do we have? Beryllium. Then we have boron, carbon, nitrogen, oxygen, and fluorine, and neon. ठीक है, ध्यान से देखिएगा. The electronic configuration 1s2, 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. In this, for sure, neon will be having the least. I mean, it will be having the least electron affinity. It does not want to. It does not want any disturbance in the electronic configuration because it is noble gas. So, if I talk about the electron affinity, then it is going to be having the least electron affinity. It does not want the electron. Now we have beryllium, which is positive, and nitrogen also, which is positive, but which will be having lower. Like both of these are going to be lower electron affinity. You know, both of them are having lower, but which is more lower is going to be beryllium because in nitrogen, when you are adding electron, that electron is going to the p subshell itself. Initially, also the 7 proton of the nitrogen atom, they were pulling electron from the 2p. When you add one electron, they are pulling one more electron from the 2p itself. But in beryllium, what happens? Right now they are in s, but when you add one electron, it will go to 2p. Right now, beryllium, the 4 protons of beryllium, they were responsible only for attracting electron from the 2s subshell. When you add electron, they will have to attract from the 2p. That will be very difficult. That is why after that we are going to have beryllium, and after that we are going to obviously have nitrogen. Now between lithium and boron, we have just seen that boron will have lower electron affinity because the electron is added in the 2p subshell. Then you will have boron, and here you have lithium. After that you are going to have lithium. Then you are going to have, as usual, carbon, oxygen, and then most is fluorine. So this is the order of electron gain enthalpy of the second period element. Copy this down. Raise your hand once you're done. Third. Now, in this, we have just discussed second period elements within themselves. Third exception is when you have second period element versus third period element. Second period element versus third period element. What happens here, please? as we go down the group, then the electron affinity decreases. So what was expected? That the second period element, they will have higher electron affinity than the third period element. But that is not the case. Expected क्या था? Electron affinity of second period should be greater than that of third period elements. But what is the actual? Actual में उल्टा है. The electron affinity of second period, it is less than that of third period. Reason? ध्यान सुनिएगा. एक तो हम आपको elaborate reason पूरा बता देते हैं. हाँ, actual पूरा complete reason है क्या? एक y का आंसर. एक why this and all of those things. See. ध्यान से देखिएगा, समझने की कोशिश कीजिएगा, ठीक है ना. वैसे तो दो चीज हैं, या तो आपको रट जाइए आप जो रीजन वगैरह सब कुछ है ना, ठीक. और थोड़ा सा अगर हम आपको ये न्यूक्लियस कर देते हैं रेड कलर से, शेल नहीं लगे आप. इज नॉट अ शेल, दिस इज अ न्यूक्लियस. नाउ second period elements will be having only till what? Only the second shell. First period में 1s1 1s1 1s2 2s1 2s2 2p6 तक होता कहाँ तक? Second period. So in second period element you will have the second period. Second period will have 2s and 2p. Second period element will have the second shell. Second shell में क्या होगा? 2s होगा और 2p होगा. So 2s can hold 2 electrons, 2p can hold 6 electrons. In total, maximum electron that you can hold is equal to how much? 8. Now, in the third shell, the third period element, they will have 3 shells, and the third shell will be having PS, PP, and 3D. Okay, PS, PP, and 3D. From which 3D is going to be vacant. Always it is going to be vacant in the third period element. Right? 3D is going to be filled in the fourth period when you have 4s, 3D, 4p. वहां पे fill होता है. Now, maximum electron it can hold is 2, 6, 10. That is equal to how much? 18 electrons. अब एक कंपैरिजन ले लेते हैं पर ताकि आपको समझ में आए. फ्लोरीन. Fluorine has electronic configuration 2,5. 2,5. 2,5. 2,5. 2,7. 2,7. Atomic number is 9 ना. 2,7. अच्छा, क्लोरीन की अगर हम बात करें, क्लोरीन इट इज गोइंग टू हैव 2, completely fill 8 and then 7. 2, 8, 7. Yes or no, please tell me guys. यहाँ तक ठीक है? अबीर, अलीना and Ali, बोलो.
Yes, sir. Yes, sir.
Now add 1 electron. If you are going to add 1 electron, it will be 2,8. Fluorine will be Cl negative. It will be 2,8,8. Make sense? Yes or no, please tell me.
Yes, sir.
Make sense? एक बार बताइए. There is one room where you can have 8 people. How many people? Tell me. How many people? Bolo. There is one room in which you can have how many people? 8 people. Bolo. How many people?
8 people. 8 people.
And you have kept 8 people in there. You have kept 8 people completely full. There is another room where you can have 18 people. How many people?
18 people.
But you have kept only 8. You have kept only. You have kept on how much? Only 8. Where you will be more comfortable? Where the people will be more comfortable, more relaxed, less repulsion? The 18 one, where the capacity of filling electron is 18 and we have filled only 8. In that case, the repulsion will be negligible if I compare it to the repulsion that we are going to face in the fluorine. That is why the second period elements, when they are going to add electron, they are going to experience a very large repulsion. Because of what? Because of the small size. ये तो पूरा elaborate reason, इतना reason आपको कहीं नहीं मिलेगा, ठीक है ना? टीचरों के पास मिलेगा, किताबों में नहीं मिलता, ठीक है? So this is what second period. That is why second period element they have lesser electron effect. Why? Reason? Due to small size of second period element. Due to small size of second period elements, the incoming electron experiences more repulsion in comparison to in comparison to the third period element. आगे बात समझ में सबको हाँ या ना बताएं?
Yes, sir.
लिख लीजिए आराम से। यहाँ पे अब आपके पास क्या क्या चीजें होंगी? देखिए, दो आपको यहाँ पे याद रखना है। इन हैलोजेंस ग्रुप 17 का ऑर्डर और इलेक्ट्रॉन एफिनिटी। यहाँ पे क्लोरीन विल बी हैविंग द मैक्सिमम, after that chlorine, then you will have bromine, then you will have iodine. And for group 16 you have to remember, for electron affinity, the most negative electron gain enthalpy or the most highest electron affinity is for what? Sulfur. उसके बाद selenium, then you have tellurium, then you will have oxygen, ठीक है? ऑक्सीजन का सबसे कम हो जाता है। बाकी सारी चीजें तो अदर ग्रुप्स के लिए नहीं। फॉर एग्जाम्पल, इफ यू कंपेयर फ्लोरीन एंड क्लोरीन, तो फिर क्लोरीन का ज्यादा है किससे? फ्लोरीन से। इफ यू कंपेयर सल्फर एंड ऑक्सीजन, देन सल्फर हैज मोर इलेक्ट्रॉन एफिनिटी देन ऑक्सीजन। इफ यू आर गोइंग टू कंपेयर, कौन आता है? नाइट्रोजन एंड फॉस्फोरस, तो फॉस्फोरस विल हैव मोर देन नाइट्रोजन। सिमिलरली silicon will have more than that of carbon, and aluminium will have more than that of boron, है ना? तो ये सारे के सारे क्या आंसर? थर्ड पेयर, थर्ड पेयर, थर्ड थर्ड थर्ड। ये बोरॉन सेकेंड 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 सेकेंड। Done everyone? Yes or no? Please tell me.
Yes.
ठीक है। उसके बाद देखिएगा आप लोग एप्लीकेशन ऑफ ionization energy and electron gain enthalpy. ठीक है, एप्लीकेशन ऑफ ionization enthalpy and electron gain enthalpy. राइट, देखिए यहाँ पे रखते हैं हम लोग डेल्टा एच आयोनाइजेशन, डेल्टा एच इलेक्ट्रॉन गेन एंथैल्पी या फिर इलेक्ट्रॉन एफिनिटी है ना, जो भी बोलिए। metals have low ionization enthalpy है ना, लो आयोनाइजेशन enthalpy और आयोनाइजेशन एनर्जी। नॉन मेटल्स have high electron affinity. That means metals are what? Metals are those that can lose electron easily without too much energy spending. If you can lose electron, that is a good metal. And what is a non-metal? Non-metal is something which releases energy when electron is added. It releases energy when electron is added. So if there is an element which is releasing more energy, then what is going to happen? It will have high non-metallic character. इसी वजह से देखिए यहाँ से जरा, if you go like this, then what happens? Ionization energy it decreases, and we can say that metallic character. Metallic character, it is inversely proportional to ionization enthalpy. If the ionization energy is high, metallic character will be low. So in a period, what is going to happen? The ionization energy it increases as we go across a period, and that is why the metallic character decreases. If I go top to bottom in a group, then we know that ionization enthalpy decreases, and that is why the metallic character is going to increase. In this case, we can say that non-metallic character directly proportional to electron affinity. If there is a more release in energy, if the energy to each electron is higher, the non-metallic character will also be higher. That is why when we go across a period, then we know that electron affinity it increases. Therefore, the metallic character it is also going to increase. If I go top to bottom in a group, then we know that electron affinity decreases, and that is why non-metallic character NMC, NMC, non-metallic character it is also going to decrease. Now, then you write elements with elements with elements with low ionization enthalpy form basic oxide. Elements with high electron affinity forms acidic oxide. एग्जाम्पल की अगर आप बात करें, फॉर एग्जाम्पल सोडियम ऑक्साइड, ठीक है, इसी तरह से कैल्शियम ऑक्साइड, मैग्नीशियम ऑक्साइड, ठीक है, आयरन का ऑक्साइड FeO, Fe2O3, ऑल ऑफ दीज आर व्हाट, दे हैव लो आयनाइजेशन एंथैल्पी एंड दे फॉर्म बेसिक ऑक्साइड. जितना कम आयनाइजेशन एंथैल्पी होगा उतना ज्यादा बेसिक कैरेक्टर होगा. Here you can have अलग अलग आपको मिल जाएंगे। फॉर एग्जाम्पल सल्फर ऑक्साइड, कार्बन का ऑक्साइड, नाइट्रोजन के ऑक्साइड, N2O5 मान लीजिए आप, है ना। ठीक है, दीज आर व्हाट, दीज आर गोइंग टू बी एलिमेंट्स विद हाई। नाइट्रोजन हटा दो क्योंकि इसका हाई तो होता नहीं है, दैट इज वाई यहाँ पे इसको न्यूट्रल भी मिल जाता है, जो कि फॉर्म कर जाता है। देन फॉर एग्जाम्पल और क्या दिया आपको, Cl2O7। ठीक है, so these are going to be etc. These are going to be what? These are going to be acidic oxide. और अगर बात करें then elements with low ionization enthalpy, for example we have some element and if it has low ionization enthalpy then it can easily lose electrons, will get impossible. uh, have you guys learned about loss of electron, gain of electron, reduction, oxidation in those terms? Abir, Alina and Ali, gain of electron is reduction, loss of electron is oxidation.
Yes, sir.
Hmm? What about Alina and Ali? अभी पढ़ा है आपने? अच्छा ठीक है, ठीक है, अभी बस लिख लीजिए तब, है ना। एलिमेंट्स विद इन रिडॉक्स रिएक्शन, वापस वी आर गोइंग टू लुक एट दिस। ठीक है, एलिमेंट्स विद लो आयोनाइजेशन एनर्जी आर पावरफुल reducing agent. Similarly, elements with high electron affinity are powerful oxidizing agent. ठीक है, यहाँ पे हम लिख देते हैं मोस्ट पावरफुल ऑक्सीडाइजिंग एजेंट, मोस्ट पावरफुल रिड्यूसिंग एजेंट जो होता है वो होता है लिथियम, एंड मोस्ट पावरफुल ऑक्सीडाइजिंग एजेंट जो होता है दैट इज फ्लोरीन, F2। इसके रीजन अलग अलग हैं, ठीक है ना, मतलब देयर आर मल्टीपल फैक्टर्स दैट अफेक्ट द रिड्यूसिंग पावर एंड द ऑक्सीडाइजिंग पावर, वो हम लोग रिडॉक्स रिएक्शन में ले लेंगे। इतना एप्लीकेशन, ठीक है, इतना एप्लीकेशन होते हैं। उसका काफी है, रेज योर हैंड वन स्टूडेंट। अच्छा, इलेक्ट्रॉन गेन एंथैल्पी में एक चीज होगी, ठीक है, इसको लिख लीजिए, फिर एक नोट लिखा देंगे इलेक्ट्रॉन गेन एंथैल्पी के बारे में। वेटिंग फॉर अलीना एंड अली। जस्ट वेटिंग फॉर अली। बिफोर मूविंग टू इलेक्ट्रोनेगेटिविटी देयर इज नोट, प्लीज राइट अ नोट। ध्यान दीजिएगा, नोट क्या है? सक्सेसिव डेल्टा एच ई जी इज ऑलवेज एंडोथर्मिक। इज ऑलवेज एंडोथर्मिक। क्या मतलब इसका? फॉर एग्जाम्पल इफ यू हैव सम एलिमेंट ए, और ए में आपने एक इलेक्ट्रॉन डाला ए नेगेटिव, so this process will be, this here delta H will be negative. That means energy will be released. Once you add one more electron to make it two negative, then the delta H, in this case, it is going to be positive, because when you are going to add electron in already a negatively charged anion, then the negatively charged anion is going to repel it. है ना? That is why the delta H initially, it was what? Negative. Initially generally negative होता है, but when you are going to add one more electron, it is always going to be positive. That is a successive electron gain enthalpy. It is always endothermic. ठीक है, एक सवाल लिख लीजिए। कंपेयर दी नॉन मेटालिक कैरेक्टर ऑफ फॉलोइंग। ठीक है, नॉन मेटालिक कैरेक्टर ऑफ फॉलोइंग कौन कौन है आपके पास? यू हैव बोरॉन, कार्बन, नाइट्रोजन, क्लोरीन एंड नियॉन, नो नॉट नियॉन, एंड सिलिकॉन। ठीक है, सो फर्स्ट ऑफ ऑल व्हाट वी विल डू, विल अरेंज देम इन द पीरियोडिक टेबल। तो ये पीरियोडिक टेबल में कैसी है? बोरॉन है सबसे पहले, बोरॉन है, देन यू हैव कार्बन, देन यू हैव नाइट्रोजन, देन यू हैव क्लोरीन, एंड बिलो कार्बन यू हैव गोइंग टू हैव सिलिकॉन। ठीक है, so like this and like this, right? So non-metallic character it is going to increase, non-metallic character as we go down it decreases. So when you are going to compare like this, so in that case देखिए सिलिकॉन का तो सबसे कम हो जाएगा, सिलिकॉन का सबसे कम, बिकॉज इट इज बिलो द सेकंड पीरियड। तो non-metallic character सिलिकॉन का सबसे कम। ठीक है, थर्ड पीरियड का यूजी। आफ्टर दैट बिटवीन बोरॉन, कार्बन, नाइट्रोजन एंड क्लोरीन, देन व्हाट गोइंग टू हैपन? बोरॉन का सबसे कम, उसके बाद कार्बन का, उसके बाद नाइट्रोजन का, उसके बाद क्लोरीन। देखिए एक बार इसको समझने की कोशिश कीजिए, पहले समझने की कोशिश कीजिए। आगे ना समझ में आप लोग आए ना बताए, मेक सेंस है? सुनो,
Yes, sir.
after this please write the heading electronegativity। लिख लिया ना ये वाला आपने? सवाल लिख लिया होपफुली। electronegativity it is shown by this particular sign that is known as psi। ठीक है, what is electronegativity? The tendency to attract electron, attract shared pair of electron, attract shared pair of electron। मतलब इन अ बॉन्ड, एक बॉन्ड के अंदर व्हाट इज द टेंडेंसी टू पुल इलेक्ट्रॉन, है ना, अट्रैक्ट इलेक्ट्रॉन। द टेंडेंसी टू अट्रैक्ट इलेक्ट्रॉन इज कॉल्ड electronegativity। is called electronegativity. Now, electronegativity इसको ऐसे ना मेजर नहीं किया जा सकता, बट इट हैज बीन इसको एस्टिमेट किया जा सकता है, कैलकुलेट किया जा सकता है यूजिंग सम पर्टिकुलर फॉर्मूला. ठीक है. तो मेजर क्या है. हाँ, so there are multiple scales. For example, it is not a measurable quantity and it can be it can be calculated. So you have Pauling scale, Mulliken scale, Alred-Rocco scale. These are different types of scale that we have. ठीक है. तो थोड़ा सा आइडिया आपको लग जाए. ठीक है. तो प्लीज यहाँ पे एक चीज लिख लीजिएगा. It is not a measurable quantity, but can be determined by calculations. तो एक है Pauling scale, depends on bond energy. सेकंड जो आप याद रख लीजिए, Mulliken scale depends on ionization energy and electron affinity. ठीक है, इतना काफी आप if you want to write one more, एक और है ऐसे एनसीईआरटी में, that third one is Alred-Rocco. If it is Alred-Rocco, the Alred-Rocco scale, it depends on Z effective and radius of atom. ठीक है. अब देखिए इलेक्ट्रॉन नेगेटिविटी किन किन फैक्टर्स पर डिपेंड करेगी. फैक्टर्स अफेक्टिंग इलेक्ट्रोनेगेटिविटी. सी हियर नंबर 1, ध्यान दीजिएगा जरा. इफ यू हैव अ स्मॉलर एटम लाइक दिस, ठीक है, एंड देयर इज अ लार्जर एटम, so sharing of electron is happening like this. Here they are having shared pair of electron. The nucleus of the smaller atom is here, the nucleus of bigger atom is here. So which nucleus can attract the shared pair of electron more effectively, the atom A or atom B? Right,
Atom A.
atom A, right? Because of the small size. First factor is size. Size increases, electronegativity decreases. Electronegativity decreases. That means electronegativity, it is inversely proportional to size. Let us suppose this size is same. Let us suppose the size is same. Now, here, let us suppose it was having 11 proton. Here it was having 17 proton. Now, which one is going to attract the shared pair of electron more effectively? Tell me. 17 proton will attract it more effectively, or 11 proton, which is going to attract more effectively?
17 proton.
17 proton, right? So if the Z effective is high, the electronegativity is also going to be high. And that is why electronegativity, it is going to be directly proportional to the Z effective. You can see the trends also now. As we go across the period, then in that case, the Z effective increases, the size decreases, therefore electronegativity, it is going to increase. In top to bottom in a group, Z effective constant, the size increases, that is why electronegativity is going to decrease. Okay, but the order of electronegativity should be remembered like this: order of electronegativity. Chlorine is the maximum electronegative element, then oxygen, then nitrogen, then chlorine. Cone, col, bro, then iodine, then sulfur, then carbon, then carbon, then phosphorus, and then hydrogen. Although nitrogen and fluorine, they have almost similar, iodine, sulfur, carbon, they have almost similar, and phosphorus and hydrogen, they have almost similar. You can remember it like this: cone, col, bro. This is ishq, this is प्यार है. कौन कॉल ब्रो इश्क प्यार है. कौन कॉल ब्रो इश्क प्यार है. Copy this down, raise your hand once you're done. Tell you. So now we can have a conclusion type of thing. In general, conclusion. ठीक है, तो स्टार्टिंग से अगर स्टार्ट करें, देन वी स्टार्टेड विद जेड इफेक्टिव. सबसे पहले हम लोग ने जेड इफेक्टिव देखा था. तो अक्रॉस अ पीरियड द जेड इफेक्टिव, बताइए जरा, मुझे याद है जेड इफेक्टिव क्या होता है? इंक्रीज करता है, डिक्रीज करता है, बताओ. जेड इफेक्टिव इंक्रीजेस और डिक्रीजेस अक्रॉस अ पीरियड. बोलो भाई, यार पूरा
Increases.
चैप्टर हो गया. बट बढ़ेगा घटेगा, इंक्रीज डिक्रीज क्या होगा? सुनाई नहीं दिया हमको ठीक से। व्हाट हैपेंस टू द
Increase.
जेड इफेक्ट? इंक्रीज ना, अप राइट। हाँ, माइक,
Yes, sir.
कैन यू गाइस कीप योर माइक ऑन यार प्लीज, हमें इंतजार कर रहे हैं आपसे। अलीना, अली, थैंक यू अबीर। टेल मी अबाउट साइंस, अप और डाउन, साइंस,
Decreases.
अप और डाउन। कीप योर
Down.
माइक ऑन अलीना।
Down.
डाउन, अप और डाउन बताइएगा, ठीक है ना। आफ्टर दैट व्हाट डिड वी लर्न आफ्टर साइंस? आयनाइजेशन एनर्जी, राइट?
Yes, sir.
आयनाइजेशन एनर्जी विल इंक्रीज और डिक्रीज, अप और डाउन?
Up.
वेरी गुड। इलेक्ट, अच्छा, if the ionization enthalpy is up, then metallic character
Down.
down, है ना। metallic character को नीचे लिख देंगे वैसे हम। नहीं, यही कर देते हैं, metallic character is going to be down. After ionization enthalpy, we learned about electron gain enthalpy or electron affinity. Electron affinity is up or down?
Up.
बताओ। up. Non-metallic character
Down.
up, up,
Up.
up, हाँ up. And electronegativity up रे भाई, अभी तो सिखाया इलेक्ट्रोनेगेटिविटी का। Now Z effective
Constant.
constant, size
Up.
increases. Ionization enthalpy
Down.
down, metallic character up,
Up.
electron affinity down,
Down.
non-metallic character down, है ना, electron affinity हाँ down, non-metallic character, and then electronegativity is going to be down.
Down.